So hey, here you go. We're doing quadratics, finding the max and min. So a rectangular piece of land bound on one side by a hedge. So this is the hedge here, is to be fenced on its other three sides. So these three sides right here was the maximum area that can be enclosed by 200 meters of fencing. That should be area right there. So to do this, what I'm gonna do, I'm gonna call this part of the fencing XX. And because we have 200 meters of fencing, then I'm gonna say this is 200 minus 2x. And that's, of course, there's no fencing there because that's the hedge right there. So we have x, and then this part will be the 200, take away these two sides right here. Now the area of a rectangle, area equals width, which is, or width times length, which is area equals x times the length is 200 minus 2x. Area equals, I'm just gonna distribute that into there, but at the same time, I'm gonna write negative 2x squared first, plus 200x. Now, when you get to this stage, you need to change this into vertex form. So you need to change it into y equals a x minus p squared plus q. Okay, and once we change it to that, we'll graph it and I'll show you how to look for your max and min. So to do this, we gotta complete the square. To complete the square, we have to go -2, take out the -2 and put x squared in here. Taking out -2 from here, that will make that -100 x. And now we're gonna complete the square. To complete the square, basically what we do, we take the coefficient of x, the -100, divided by 2 and square it. So that's what we do every time we complete the square. So you take the coefficient of x divided by 2 and square it. -100 squared is 50, 50 squared is 2500. So you plus 2500 and you minus 2500. Yeah. Now, this -2500 that we minus, because we want to add 0. 2500 minus 2500 is like 0, and if you add a 0 to the equation, it doesn't change it. But of course, we're not gonna replace this by 0. We need this to complete the square and make it look like this. Now, the first thing I'm gonna do is I'm gonna just keep the so -2x squared minus 100x plus 2500. I'm gonna take this out, but when you're taking it out, remember to multiply it by the -2, which gives me 5,000 positive. Negative times negative is gonna be positive 5,000. Now, this will factor into, so once we complete the square, you see this part right here, it factors now because it's a perfect square trinomial. And to factor, just put x, and then the sign after the x squared goes here, and then half of the 100 or square root of 2500, both of these give you the same answer. So half of 100 is easier to do it right now. So minus 50 squared, and then you still have plus 50, plus 5,000. Now, if you're asking me like, how did you get from here to here? I say to you, if you take this and FOIL it, you'll get this back. Or you basically, we factored. We're looking for two numbers that multiply to give you 2500, yes, and add to give you -100. That's going to be -50 times -50 will multiply to 2500 and add to -100. So it's x minus 50, x minus 50. And instead of writing it twice, we just put a square there. But when you complete the square, just take a shortcut, put an x there, the sign after the x squared goes there. Half of the 100 is 50, or the square root of 2500, which is 50, just put it there. Now, if I'm gonna plot this, I'm gonna just change my windows right here. I'm gonna change my scale basically on the x and the y axis. So now, since I changed my scale here, the first thing is to find out what my vertex is. And my vertex will be 50 and 5,000. So 50 and 5,000, so 50 is right here and 5,000 is right there. Now, you know, because this is negative, this is going to open down. And maybe we should find out what our y-intercept is. So y-intercept, so basically you sub in 0 for x. So that's negative 50 squared is positive 2,500. And times negative 2 is negative 5,000. Negative 5,000 plus 5,000 gives you 0. So basically then, when x is 0, y is 0. So if you look at here, if you remember how to graph parabolas, this is your axis of symmetry right here. And this is 50 away from the axis of symmetry, so you go 50 away from the axis of symmetry, and you get your other point right there. Now, we're just gonna graph this parabola right here. And now, see here, this is your maximum value. So here, because this here, what we're plotting the area against the x value. So this point is at 50 and 5,000. And therefore, your maximum area, and I'm just gonna write the answer right here, max area that enclosed in there is 5,000 meters squared. And that's it, that's all they asking. If they ask you for the dimensions, then you'll know that the width has to be 50 because that's your x, represents the width. So x has to be, or the width has to be 50. And the length is, as you see, is 200 minus 2 times 50. 2 times 50 is 100. 200 minus 100 gives you 100. And that's how you determine the maximum area. And if they ask you further to find out what's the width and the length that will give you the maximum area, then it's the x value here that represents the width here. And therefore, the width would be 50. And then you could just find the length from right here because that's the length of the rectangle. Okay. So always your vertex represent either a maximum or a minimum. If your parabola is opening up, you have a minimum. If your parabola is opening down, you have a maximum. And what determines if the parabola is opening up or down is the a value. You know, so if a is negative right here, then your parabola is opening down. So if it's opening down like the one that we have, you'll have a maximum. But if the parabola is opening up, that means the a here is positive, then it represents a minimum. And that's it. As always, thanks for watching. Bye-bye for now.